6th grade math lesson 3.3 rational numbers and the number line. Rational numbers are the whole grouping that includes whole numbers 0, 1, 2, 3, blah blah blah, integers 0, 1, 2, 3, and their opposites -1, -2, -3, blah blah blah, and the in-betweeners, the ones that I call in-betweeners, any decimals or fractions that fall in between those whole numbers and integers. So that's what rational numbers all encompass. Any rational number can be written as a fraction, and in the book they use A over B. They use that this year, and next year you'll see that too. That means any number, if A represents any number other than 0 and B represents any number other than 0, if a number is able to be written as a fraction, it is considered a rational number. So let's say I have the number 2. I can write that as a fraction, 2 over 1, right? The decimal 0.25. Well, you know 25 cents is 1/4. That can be written as a fraction. So those all fall under rational numbers. We went over repeating decimals and terminating decimals. Or maybe I've confused you with my 7th grade class, I don't know. But a repeating decimal would be something like 3, 3, 3, and it goes on and on forever. You could just put a line over the 3 indicating that's going to go on forever. I don't need to write that down forever. You could write it as 0.3 repeating. Those can be written as a fraction. I'll teach you how that works at 8th grade. And then terminating decimals that don't continue on and on at all, but they just end, they terminate at a certain point. Those can be written, as you well know, 25 over 100 because it ends in the 100ths place, and then reduce it down. So any decimal that is either a terminating decimal, it ends at a certain point, or if it continues on and on and on forever, it continues in a repeating pattern like that, 0.25, 25, 25, 25 forever. If there's a repeat, then all of those can be written as a fraction and is considered a rational number. So the first example our book gives us is unlocking the problem, and it gives us a word problem. Whenever we see word problems, we should remember to follow our steps, read the question, underline what you're asked to do. Step 3, circle any information that was provided to you. Step 4, draw it if it would help you. In this case, it's going to be a number line, so they're drawn for us. And step 5, solve it, whatever needs to be solved. So let's take a look at that and do these steps with this problem. Step 1, we're reading it. The freezing point of a liquid is the temperature at which the liquid turns into a solid when it is cooled. The table shows the approximate freezing points of various liquids. Graph each temperature on a number line. That's what they're asking me to do, so I will underline it. And they gave me the number lines to go with it. Where is the information that's provided? It's over here. Sometimes it's not even in the word problem. It's off to the side in a table. In this case it is. We have carbonated water. That's freezing point is -0.3 degrees Celsius. Fizzy lemonade, -0.5 degrees Celsius. And hydrazine, which is a freezing point of 1.4 degrees Celsius. That's a positive. So that's the information provided. I can draw the picture, but they have drawn it for me. I just need to find those points on the line. I'll remember though that these are all in the 10ths place. So I kind of want to have 10 pieces split between each one. And I notice here that I have 1, 2, 3, 4, 5 between each whole number. So if I double that, if I had little tiny hash marks in between, that would give me a total of 10 broken pieces in between. So I'll keep that in mind as I do the graphing of that, because that is a -3/10, 3 out of 10 pieces. And so now that I know I can get those into 10 equal pieces, that's how I'll use that. So let's graph this -0.3. So first I need to find 0. Here it is. And I'm going to go in the negative direction. It is 0 and a little more, but not enough to be 1, negative 1. So it's going to be in between here, negative 0.3. That's 3/10. So remember, these dashes are counting as 2/10. So 2/10 there and then one more there makes this one go right in the middle there. Negative 0.3/10. That is for carbonated water. Then we're going to look at negative 0.5/10 or 0.5, negative 0.5. Again, it's 0, it's 0, and then it goes negative a little more, but not enough to be 1, or else that would say negative 1, right? So it's in between 0 and negative 1 again. And it's 5 out of the 10. Remember, these are counting by 2s because there's 5 broken pieces and I need them 10 broken pieces. So 2, 4 is that one. So right in between there would be 5/10. Right there. That is fizzy lemonade. Finally, we're graphing positive 1.4 degrees Celsius. It's 1 and some more, but not enough to be 2. So we start at 0 and we go 1 full and some more. And we want to go up 4/10. These are 2 apiece, right? Because we're breaking that into 10 equal pieces. So 2, 4, right there. That's hydrazine. I don't know if that's the abbreviation for it, but there we go. Hydrazine. Okay. Now I just need to compare them. They wanted me to graph each temperature on the number line. Now we're going to find out what's between where. 0.5 is between 0 and negative 1. 0.3 was between 0 and negative 1. And 1.4 was between the whole numbers 1 and 2. And that's how we narrowed down where to find those. The least amount is the frozen lemonade. The next lowest amount is the carbonated water, and then the highest freezing point was hydrazine. All right, the next example they give us on practicing using rational numbers and placing rational numbers on a number line deals with the fractions instead of the decimals. So remembering place value on our decimals, that the tenths place is to the right of the decimal, the hundredths place broken into 100 pieces. This time we're using the fractions, and the denominators are telling us how many broken pieces we're talking about there. So again, I'll follow my steps for a word problem. I'm going to read it first. City Hall is located at point 0 on a map of Maple Avenue. Other points of interest on Maple Avenue are indicated by their distances in miles to the right of City Hall, positive numbers, or to the left of City Hall, negative numbers. Graph each location on a number line. So I have a negative 3/8, a negative 1 1/2, a positive 1 1/4, and a positive 3/4. So this negative 3/8 it doesn't have a whole number in front of it, so it's 0 and a little bit more negative. So it's between 0 and negative 1, somewhere in between there. So when we graph that, it's going to live somewhere in between here. Let's go ahead and look at where that falls. So again, 3/8, I'm looking at its decimal. That means broken into 8 equal pieces. Well, let's see what they've broken it into. 1, 2, 3, 4, 5, 6, 7, 8. Well, that's nice. I needed it broken into 8 equal pieces. And of those 8 equal pieces, I'm crossing over 3 of them. 1, 2, 3, mark it. That's how far City Hall will be from, that's how far City Park will be from City Hall to the left of it. Let's look at the next one. This is negative 1 and 1/2. So it crosses over negative 1, and then it continues past it, but not enough to get to -2. So it's going to fall somewhere between -1 and -2. And now let's find that in between there. So between -1 and -2, I've already done -1, and I just need to do the half of it. So 1 out of 2 pieces, that's 1 piece, that's 2 pieces. If I broke it into 2 fair pieces, I'm crossing over one of those 2 fair pieces. In fact, I'll mark it there so your brain can see. I'm splitting, because the denominator says 2, I'm splitting -1 and -2 into 2 equal pieces. And I'm going to cross over one of those equal pieces to find out where the fountain is compared to City Hall. The library is located on the map at positive 1 1/4. 1 1/4. That is 1 and a little bit more, but not enough to make another whole number. So 1 and some more, but not enough to get to 2. So it lives somewhere between 1 and 2. Let's find where that lives. So we're going to cross over 1, and then from here, we've already done the 1, we're on the and 1/4. I want this broken into 4 equal pieces because my denominator is a 4. So right there, there, and there, 3 hash marks will give me 4 segments. 1, 2, 3, 4 segments. And I'm going to cross over, oopsie, I'm putting that on the wrong line, aren't I? 1, 2, 3, 4 segments. And I'm going to cross over 1 and one of those 4 broken pieces. So I will go right there. And finally, I'm going to look at 3/4. This doesn't have a whole number in front of it, so 0 and a little more positive. That's a positive 3/4. So this is going to start at 0 and go a little bit more, but not enough to make it 1. So it will fall between 0 and 1 as its whole numbers. And I need that broken into 4 equal pieces. So I will break that into 4 equal pieces. 3 hash marks gave me 1, 2, 3, 4 segments, 4 equal pieces. And I will be crossing over 3 of those 4 equal pieces. So from 0, 1, 2, 3 of those segments lands me right there. And there we are with our graph, each location on a number line. City Park, the fountain, the library, and the mall. This lesson is mostly about just getting you familiar with where those numbers fall. Best thing I can tell you is find the whole numbers that they will go between, like they did here. They helped you do that step there. And the second thing to remind you is that between those number lines, if it's a decimal, like 3/10, remember this is the 10ths place. That means between the whole numbers, you would break it into 10 equal pieces. Hopefully they don't give you a 100ths place, so you're not breaking it into 100 equal pieces. If they do, round it and make it easy for yourself. Round to the 10ths place, because you're not going to be able to mark it on that number line probably anyway. If it's a fraction, then you break those pieces into equal pieces according to the denominator. This would be broken into 3 equal pieces between one whole number and the next whole number. So those are the pieces of information that you'll want to utilize as you break those in-betweeners into their spots. It will take practice, but you'll get good at it. Just go ahead and give it the practice it needs, and let me know if you need help.